Coming up next on EIU Conversation, a tour of Eastern Illinois University's Renewable Energy Center with Dr. Bill Perry. Stay tuned. Dr. Perry, welcome again to the show.
It's good to be back.
Let's talk
Jack,
a little.
good to see you.
Good to see you, and we dressed for the occasion here.
Yes, we did.
Let's talk a little bit about this this amazing facility behind us. How did this come about?
Well, we had a problem a few years ago with an old steam plant that was on its last legs. We knew it had to be replaced, but we also knew that state funding was unlikely. We knew we didn't want to put a big fee on our students for such a new power plant, steam plant. So the people of Eastern went to work, put their creative thinking hats on, and came up with this idea of a biomass-fueled steam plant as part of a large energy performance contract that would pay for itself in savings over a 20-year period. That way, we financed it that way, and we didn't have to charge the students, and we didn't have to take any money from the state.
It seems like very much of a unique project.
Well, it is. There aren't many biomass plants on universities in the country, and we are the second largest in the country in terms of the 27,000 tons of biomass that would gasify each year to supply all the steam for the campus.
How long did this process take from the beginning to where we are now of actually getting this online?
Well, roughly speaking, there was a year of planning by our folks in the university. Then there was a year of work with the General Assembly to get permission to do this as a power plant, and then a little over a year and a half for construction. So what people see here today is the result of 3 or 4 years of work, a lot of community conversations, a lot of interaction with the community with regard to the appearance of the plant and its function.
Looking at the appearance, it's an amazing facility and quite attractive to look at. Yet you're in an area here which has some commercial, some residential, a lot of neighbors in this area. What did that mean to the project? What kind of issues did you have to deal with?
Well, our initial plan had something that was more industrial in appearance. We got some very strong reaction to that from the community, so we met in a series of meetings at the Carnegie Library downtown and found out that the appearance was a very, very important part of the project for the members of the community. So we went back to the drawing board and came up with what you see here. There were other issues that came up. One was, where would the entrance be for the trucks bringing in the biomass? The original plan had them coming in right over here off of Highway 130, but the community suggested that coming in off of Edgar Drive down here would make more sense. They felt much more comfortable, they felt safer with that. So working with the city, and had great cooperation from the city, that's where the entrance is down there for the trucks bringing in the biomass. So there were a number of things that the community suggested. We certainly agreed to as many of them as we could. There were some we couldn't. But some of the things you see on the general site here, some of the tree plantings are there for appearance sake and other reasons. We've kept the farmland for right now. We'll be using that for biomass plantings and so forth, research and education, but we'll be talking more about that later in the conversation.
Indeed. Well, we're still here. The water feature out front, that's amazing. Is it what it appears to be, which is just a very attractive waterfall?
Well, it's like an iceberg. What you see is the tip of the iceberg. Underneath the ground is a 30,000 gallon retention pond, if you will, or container. And you see when you build a building here, where before there was just earth, the rain that would come and soak into the earth before now falls on a roof. And so now it comes rolling off. By retaining it here before allowing it to move downstream, we're also being friendly to our neighbors to our south, where the drainage from this property goes. That slows down the current.
What have you learned in this process of bringing this again to the point now where we're just opening up? What surprises did you have?
Well, I think one of the surprises we had was once we made the changes, how quickly the community came to support the project. Also, the number of ideas that came up then as a result of this Renewable Energy Center with regard to things we could do to connect with the community schools. I mean, I envision this plot of land over here where we plant these different biomass species being a place where we can bring students for field trips. I see that we can bring junior high and high school science students here to learn about biomass and gasification. We're going to have a research scale gasifier and then a commercial scale so they can look at all the science, pure science, and applied science that comes out of that. We've created a Center for Clean Energy Research and Education, which is going to be a great benefit to our faculty and students here, going to really move us forward in terms of a master's degree in alternative energy. We've got a minor planned, and eventually there'll be an undergraduate major in this area as well. So the spin-offs, I guess you'd say, have occurred more quickly, and there have been more of them than I had originally thought.
And we're over at the adjacent acreage to the facility. Dr. Perry, tell us a little bit about what's here now and what are we planning down the road?
Right. Well, Jack, here's some soybeans. This acreage, and there's about 8 to 10 acres here. We've planted that for several years in different crops, and we've received income off of that. But what we want to do with this area now is just over here is where we're planning a building for our Center for Clean Energy Research and Education. We want to have some incubator space in there too, because we believe that there'll be some startup businesses coming off of the biomass research that we're doing. So that'll be an opportunity for us to support the economy of the region here. So we're going to change this from these kind of plantings to plantings of sustainable species that then we can harvest then and use for research. We can do research scale gasification of the species. Also, the different species, as I said, would give us opportunities for students to come in and see what these look like. These could be students from all the way from elementary school, kindergarten, all the way through high school. One of the great things about this site is we'll be able to grow these species here. Then we'll be able to, in some cases, we'll have to compact them or densify them. Then we can do the research scale gasification here. And if something looks promising in terms of energy output and so forth, then we could go into the plant, into the Renewable Energy Center, and do a commercial scale gasification. One of the great things about this plant is that we have two biomass gasifiers in the plant, and one of them is sufficient to do, I think, around 95% of the campus load. So the second gasifier there is to provide extra capacity for our new science building, for example, and any other new facilities we might build. When we take a gasifier down for maintenance or whatever, then we could schedule it for some of these commercial scale burns, and then we could do the analysis on the large scale. So we can do the whole process from research to commercial application. And of course, our students and other students can come and join us and learn about that whole process.
What kind of species are we talking about most likely starting with out here?
Well, right now, starting out, probably miscanthus and switchgrass, and a lot of people have heard about that. Miscanthus is a product that ends up being kind of bamboo-like, and you chop it up, it's about the size of your little finger, say. But in the long run, we might plant some kinds of fast-growing tree species that over a 7-year period then can be harvested and chipped, and we could use that for gasification as well. All the research we'd be doing here would be applicable to the region. There's plenty of farmland here that people have in soybeans and corn, and that's unlikely to change. But it's possible that we could use corn stover, the leftover residue from harvest, densify some of that and use that for a mix in our biomass gasifiers. And so there's a potential market for farmers in the area to sell some of that. On the other hand, there is some land in the region here that's not planted in those traditional crops, bottomland and other types of land that one might go ahead and plant one of these species, harvest it, and then have another cash crop.
So you're going to really provide the test plot, if you will, for all of this.
This will be a great test plot, and there may be other areas in the region here where we'll be able to plant and test other species as well.
We headed to the west side of the building where the wood chips are unloaded and stored. Approximately 5 to 7 trucks per day from a supplier in Missouri enter the facility to be unloaded. Each truck holds about 20 tons of chips. The truck is parked on a 70-foot-long hydraulic lift that elevates the truck to a 63-degree angle. The lifting process takes about 5 minutes from start to finish. Gravity drops the chips in the conveyor system. Before heading to storage, the chips pass through a detector, which discards any metal objects. From here, they're deposited into the wood chip storage building. The storage facility has a capacity of 100,000 cubic feet of biomass. On average, that's enough to run the campus for about 10 days. To remove the fuel from storage, a reclaimed screw auger removes chips from the bottom of the storage pile and deposits them onto the conveyor for transport into the gasification units. This reclaimed screw auger is 50 feet long and weighs a whopping 12 tons and is the largest one of its kind in the Western Hemisphere. Dr. Perry, where are we now and what happens here?
Well, what we're in right now is the storage facility for the wood chips, which is our primary biomass source. And you can see that these are chips of wood. These are hardwoods. We get them from an aggregator, a company that pulls together these chips, and then transports them here. And then the trucks come in. They're offloaded with a big truck tipper over here, and then all those chips come into here. And the source is from the lumber industry. When they cut down a hardwood and they're going to use it for veneer and other kinds of products, the top of the tree isn't of much use. So instead of just leaving them lying there in the forest and decomposing, they can be chipped and then shipped, and then we can gasify them here. And we'll explain more about that process inside. But biomass is less dense than coal. Coal is also biomass. It's just that centuries and eons of time and pressure really compactify it. So the storage for biomass is larger. That's why we have this very large facility here, and all the chips in here. This keeps the wood from the elements, so it's got the right moisture content for all the gasification process and so forth. And now remember, we have a backup fuel of natural gas. So if for some reason the trucks couldn't get here to give us the chips, or certainly at the times we take the gasifiers offline for maintenance and so forth, natural gas is our backup, which is a very clean burning fuel, of course. And then we have a third fuel source, which is fuel oil. It's in a large container, a large drum over here behind a limestone wall, so it's not underground where there's the potential for contamination. So we've got all the redundancy that we need, even in the most severe of emergencies, for example, in the winter, for example.
Right now we're set up obviously to burn these wood chips. What kind of a change do we have to make to the facility if we were going to burn something else, corn stove or some other product?
Well, first, of course, we'd have to do the research and analysis to make sure that the mixture would work, would meet manufacturer specifications and so forth. But once we were confident of that with some research scale burns, then we could do some test gasifications in the commercial facility. And if that all worked out, then we would clearly be able to bring in some corn stover or whatever the other biomass would be that we would mix in. If it was corn stover, for example, one question people might ask is, how much would you need? Well, in Coles County, we would need at most 10% of the corn stover in order to do a 50-50 burn. And what that means is that farmers wouldn't have to worry about having stover left over to plow back into the soil, which is an important sustainability issue as well. So the potential is there for a regional biomass market of that sort to develop. Also, potential for miscanthus or other kinds of sources that we could mix as well. We will start looking at that this year in terms of a research scale kinds of burns and that sort of thing. But then a year from now would be the soonest we could start doing commercial scale. I've been interchangeably using the words gasify and burn. When we gasify these wood chips, they're in a very low oxygen environment, and because of the chemistry and everything that I don't understand, I'm just a math teacher, okay? It forces this gas, this very clean burning gas out of that, and then that's what actually creates the flame and boils the water and creates the steam. And then what's left over is a real fluffy kind of ash which has a high nutrient value, which can then be used to go back into the soil as fertilizer, for example. So if I say burn, I really mean this gasification process. So it's not like what happens in your stove, in your fireplace, or your stove at home.
The biomass gasification process is extremely clean with respect to air emissions. Mainly producing synthetic gas to burn in the boilers, the gasifiers are equipped with dust cyclones to capture any fugitive particles which might be produced in the combustion process. For final cleaning, the gases are passed through an electrostatic precipitator before the exhaust gases are emitted into the environment. Out on the south side of the complex are two distinctive features that are hard to miss. Just another example of how the Renewable Energy Center is helping to reduce EIU's carbon footprint.
Well, this is part of a larger effort in the construction of the facility, the design of the facility to be friendly, energy friendly. And so actually inside the plant, there is the steam that's generated actually does a little cogeneration of electricity to help power the electrical needs of the plant, and this adds to that. These solar panels, if we could stay here long enough for time-lapse photography, you'd see them turn and tilt so that they're getting the maximum angle of incidence from the sun to maximize the electricity you're getting out of these solar panels. So this is another opportunity for our students to learn about that as well. So what we've done in the construction of this facility is try to get LEED Gold certification, Leadership in Energy and Environmental Design, as LEED. And we were on track to get gold, but I'm not sure what the final outcome of that's going to be. So this building, besides being responsible in just burning biomass, it's also responsible in terms of the load that it does not create on the electrical grid for its own operation.
Back on LEED certification, tell us a little bit about that, and especially at the gold level, what we're trying to achieve.
Well, LEED certification has to do with the materials you use. Can you use recycled materials for the building of a plant? It has to do with water retention and a number of issues that are all related to the environment. Also, the use of solar and other sustainable types of energy for the operation of your facility. So it's lessening the environmental impact of a new facility. And there's a number of criteria that have to be addressed, and it really depends a lot on how well you do your design and execution of the structure, but we've done a great job here with this one. So there are different levels of LEED certification, and there's platinum, which is the highest, gold, which is second highest, and then silver under that, and then just plain LEED certification there. To get a power plant with LEED Gold certification is pretty darn unusual. And if we achieve this, we'll be one of the few, if not the only, power plant to receive that kind of certification. Well, once the building is completed, commissioned, and all the analysis can be done and the paperwork gets filled out and sent in, then we'll know the final determination. That's likely to happen next year.
The next part of the tour takes us inside the plant, which serves as both a working power plant and an educational facility. The Renewable Energy Center has 4 boilers. 94% of the time, any single boiler can meet the campus demands. During periods of higher peaks, a second boiler can be fired up to meet the needs. Sight glass on the biomass burners allow visitors and operators to see inside the biomass burner. The view on the inside is not unlike a typical natural gas-fired boiler process. The entire facility is monitored and run from a high-tech control room.
Everything happens here. I mean, the really great thing about technology, this plant compared to the previous one, is that you can control everything from here. You can see everything that's going on these computer screens here, everywhere from every step of the process. From the truck coming in, dumping of the chips, the movement of the chips, moving them into the plant for gasification. You can see the whole thing right here and control it from right here.
What kind of monitors do we have here? What are we really seeing happen on these displays?
Well, what this is just a display of exactly what's going on in every part of the plant. Conveyor belts, the truck tipper, the resizing of chips, the whether you've got gasification going on in a boiler, the whole process, all the way to the ash dropping out into the ash bin at the back.
We've seen the importance of this control room to the plant. What kinds of opportunities will students have here?
Well, students will have the opportunity to come in and see, first of all, the technology and how that works, and also how the operators use the technology to track the process, keeping up with the pressures and temperatures, all that vital information. Also, the students will be able to, in a tour, after seeing this, then touring the whole plant, they'll see in real scale what was on these computer screens. So it'll give them a great introduction to the whole industrial process.
What other rooms are in this facility? We have basically some conference rooms. We have a number of facilities within here. Let's talk a little bit about what exists within this building.
Well, there is on the north end a classroom, if you will, where people can come in from the community who are going on a tour, or just people who want to learn something about it. Maybe, for instance, students from the Academy for Lifetime Learning. If they wanted to come in and learn about it, we would have that classroom on that end for them to see that. Obviously, you have support rooms, restrooms for the staff who work out here. But otherwise, it's a plant. It's a working plant.
You've got a little bit of old and a little bit of new. We're bringing in, and you actually have brought in a little bit of the old plant as a backup to what we've built here. Is that not true?
Well, in the old plant, when we knew the coal-fired boilers were failing, we knew we had to have some backup there. So we brought in a natural gas-fired boiler, exactly the same model as the one I was pointing out to you out on the floor there. And that's going to be moved in either this week or next to this plant from the old steam plant. Then the old steam plant ultimately will be repurposed for student services functions.
Dr. Perry, what's the value of the facility to Eastern and the community?
Well, it brings value to our students and faculty and our community in terms of the research and teaching and public service that we can accomplish with this facility. Also, it will provide a boost to the regional economy as we build a biomass economy. One of the things that's really gratified me is that as this project has developed and blossomed, I've realized that we're doing more than generating steam here in this plant. We're generating a future for Coles County and for Eastern Illinois University. And I'm proud that EIU is a linchpin in that process. And we're looking forward to partnerships with industry, with the schools, with everyone in the region to make sure that this really does fulfill all that promise.
The grand opening ceremony for EIU's Renewable Energy Center will take place Friday, October 7th, beginning at 2 p.m. Those interested in an up-close look at the facility are invited to come early or stay late for guided group tours. Tours will be available beginning at 1 p.m. prior to the ceremony and immediately afterward. Limited parking is available at the Energy Center, so visitors are asked to park in the textbook rental lot located at 975 Edgar Drive. Shuttle service to the Renewable Energy Center will be available. Thanks for watching us on another edition of EIU Conversation. See you next time.